The channel just hit 2,000 subscribers. Thank you so much, guys. And to celebrate, went cliff jumping with some friends. Of course, no one could decide how tall the cliff was, so we turned to physics. Here is our cartoon scenario. We're jumping off a cliff of unknown height into the water. We can use a kinematic equation from physics to solve this very easily. Note that x is position, v velocity, a is acceleration, t time, and that zero subscript we see on the v term right here, that means it's the initial state. These equations describe motion from an initial to a final state. We also need to define our axes. To the right is positive x, and upwards is positive y. Note that we're falling downwards, so we'll actually have a negative distance traveled. Gravity is also acting downwards and will be a negative quantity. We're only going to do an analysis in the y direction. There's no change in acceleration or velocity in the x direction, so it's not very exciting. Plus, we only care about the distance I've fallen, not the distance that I traveled outwards from the cliff. So we'll look at just the y direction, and hence our equation up top is now in the delta y, because the kinematic equations don't care if you're in x or y directions. The initial state is the instant right before I jump, and the final state is the instant right before I hit the water. We know some information, such as the instant right before I jump, I'm not moving, which means there's zero velocity. Also, acceleration due to gravity is negative 9.81 meters per second squared, and the time I just got from the video, which is 0.96 seconds. I'm going to throw this into MATLAB so we can see some cool behavior for different heights and different times. Huge shout out to my first ever patron, Sujen. Thank you so much. Sujen is subscribing all the way from Australia, and because he's the highest tier, we work together one-on-one via email to solve some of his current projects that he's working on. Here is the script I put together. The initial lines 4 to 6 just define the basic variables we're using. Line 9 calculates the delta y, which comes out to be negative 4.5 meters. That value is negative because we're falling downwards off the cliff in the negative y direction. And then I did an array of times here as the capital T, which calculates an array of distances fallen, capital Y, and that way for any given time that you're in the air, you can calculate how far you would have fallen. If we run this, we'll get the graph, and here you can see if you were falling, for example, 3 seconds, that equates to having jumped from the cliff of 50 meters tall. Thanks for watching, and have a great week.
Do something cool.